If you want to classify motions, there will be 4 to 5 branches. And one of those branches is your linear motion. Linear motion is a motion along a straight line. For example, say an object starts its journey from O. So this particular example has this particular diagram associated with it. So the object starts its journey from O. O is your reference point, or you learned this as origin. So O is your origin. At first, the object moves through C and B, reaching A. So the robot moves from O to A. Then it moves back along the same path, reaching B. So end of it, the robot moves, not B, sorry, correct, to C through B. That is basically the robot moved from origin to point A and from A back to C. So this is the entire motion. So we can talk about any kind of motion with this terminologies: distance, displacement, time, speed, velocity, and acceleration. In this particular example, the total distance traveled is 60 plus 35. Right? From 60 to 25, the gap is 35. So in total, the distance traveled by this robot is 95 meters. Right? The scale over here is over here. The scale is over here. So the robot moved 95 meters in a straight line. Remember, this is a linear motion because the robot is moving just back and forth on a single line. Right? The total displacement is from the origin to the last point, to the last destination point. The distance from the origin to that point is your displacement. So in this case, 25 meters. So what is this displacement? We'll understand that in time. So here the displacement for this particular example is 25 and the distance is 95. We'll be looking into this difference and all of these terms in detail in the coming set of videos. The whole chapter has to do with this itself. So, all these terminologies and numericals and derivation and everything. So this is just an introduction.